Okay, so this is the last video in the series on gas stoichiometry, and this is where we're actually going to talk about how we do gas stoichiometry. The other parts were just build up. So as a reminder, stoichiometry is the way that we relate the masses of two compounds in a reaction. And the pathway forward is mass A to mole A, mole B to mass B. Or we can remember GMUG. And but we don't use mass for gases. Instead, we're using volume, and to relate moles and volume, we have molar volume, and that's at STP. But we're just going to assume most of these happen at STP. So for stoichiometric problems with this should all look familiar from earlier this unit, where we've talked about how if we're going from mass to mole of a compound, we want to use molar mass. And if we're going between two moles of a compound, we use molar ratio. And so here's where we had GMUG. And here was like MUG. Now we have this additional piece here where we're going from volume to mass of different compounds. And again, we can't go directly between them. Instead, now we're going to be adding volume to our pathway, and we go from volume to mole of the same compound. We're going to use molar volume. So now, instead of GMUG, we have VMUG. But you can also do, so anywhere we see the G, oh my goodness, the G, wow, the G, we are able to replace it with V, and we could also have like GMUV. All right, so we're able to just put volume in place of mass there. So let's do a problem. So here we're asked if we burn 85 liters of hydrogen, how many liters of oxygen would be used up? So we're given 85 liters of hydrogen. We're looking for liters of oxygen. So the first thing we want to do is write out our pathway. So we're going liters of, not oxygen, liters of hydrogen to moles of hydrogen, moles of oxygen to liters of oxygen. To go from liters, so now we have our pathway. Now we're going to write out what conversion factors are needed. So we're going to need a step every time we see an arrow. So to go liters to moles, we're going to use molar volume. So that's 1 mole of hydrogen for 22.4 liters of hydrogen. To go from moles to moles, we use molar ratio. And we get those from the coefficients. So we're looking at just these two here. So we have 2 moles of hydrogen for every 1 mole of oxygen. And then our last step here, going liters to moles again, we're using molar volume. So 1 mole of O2 for every 22.4 liters of O2. Now we can solve. And we always start with what we're given for solving. So we're going to put 0.85 liters of hydrogen. We're going to plug this in so that our liters cancel. Now we're going to put the next one in so that the moles of hydrogen will cancel. And lastly, putting this in so that we have liters of oxygen on top and the moles of oxygen. That's a 1. Moles of oxygen on bottom. So checking this, we see the units along the top here match our units in the pathway. We can also cancel our units that are on opposite sides of the dividing line, and showing we're left with liters of oxygen, which is what we're looking for. So if you plug this into your calculator, you should get that it would burn, or how it would use up 0.43 liters of oxygen. All right, give this one a try. All right, so for this one, you should have found that the answer was 0.69 liters. If you didn't get that, come and see me. Oh, one thing I will say, an important thing to notice here with this is we're in grams of magnesium. Remember, molar volume only applies to gases, so you wouldn't be able to do this with you want to use molar volume here. When you're going grams to mole, you still want to use the molar mass. All right, that's it. And that's it for gas stoichiometry.